in which the axis, major and minor axis, are not equal. But it's a set of all points such the sum of two fixed points is constant, which is really cool. That's why I'm going to show you this picture. But these points here are called the foci, or it's called a focus, but you don't say focuses, you say foci. If you at any point drew a line on this ellipse and you connected these two, the sum of these two lines is always the same and everywhere on an ellipse. So like over here, this sum is the same as that sum there. And so it's really cool. You can take I used to take a thumbtack and a piece of string and show this before I had a smart board. But see, look, there's the two foci, and you can take and you can connect and you can draw a perfect ellipse every time if you have your foci points. Isn't that kind of cool?
That's so cool.
You seem unimpressed, but just like with a center, like a circle, you can take the center and draw the circle. Well, an ellipse is a stretched out circle, so you have to have those 2 points, the foci, to do that. I know, right? So what do we need to do? We need to be able to graph it. We need to be able to find all the stuff from it. So the two fixed points are called the foci. We call those F. They have two axes of symmetry, the major axis and the minor axis. The minor axis is the shorter axis. So you can have an ellipse that looks like this, where the major axis is going horizontal, or you can have an ellipse that looks elongated like this, where your major axis is vertical. And so just like with a parabola, there's two sets of equations, whether it's opening left or right or up or down. With an ellipse, there's two sets of equations, depending on whether it's longer sideways or longer vertically. And then this is called the center. They call the vertices the points of the major axis, like the endpoints here. You want to label those V for vertices. But I think on the next slide I have a bunch of other stuff listed out for you. So again, I'm going to give you two sets of equations. One, if it's centered around the origin, because it's a lot easier to kind of see those. But it's not going to all be centered around the origin, so if it's centered somewhere else, we're going to call that H and K. But I want to give you kind of the important pieces from this. So if the form of the equation is x squared over a squared plus y squared over b squared equals 1, then that is going to, does yours look like this? Is it all squished over like this? Why does it do that when I save this? See how this looks different than yours? Mine looks ugly. It doesn't, like this. There's space like this. See what I'm saying? Annoying is what. So, if it's going like this, that means it's like a horizontal vertical axis, or major axis. I don't know, that's a terrible ellipse. My ellipses always look like footballs or eyeballs. And if the y squared is over a squared, then it's vertical. Like this. The foci are the c value that we'll talk about in a minute, plus or minus c, comma 0, or 0 plus or minus c, because depending on which way it's going. The major axis is where the foci are located. So if it's going horizontally, then the foci are plus or minus c0. If it's going vertically, then it's 0 plus or minus c. The length of the focal axis, which is the length of the major axis, that's another way to say that. Major axis, the longer axis, is always 2a units. And the length of the minor axis is 2b units. And the vertices are 0 plus or minus a. Is that right? A plus or minus 0. We'll find that out in a minute. And just know that a is the bigger number, right? So a and b are both bigger than 0, but b is the smaller number. We can also say there's a relationship between a, b, and c. And I think, is it just Pythagorean theorem? Let's go back and look at our picture. is 2a, right? The length of this is 2b. We can say this is b. The distance from the center to a foci is c. Ooh, and so this is a. So I think it's a squared equals b squared plus c squared. That's a little tricky, right? Because we're used to. No, is that what we always say? No, we say c squared, right? Let me. Yeah, which is not true on this. A squared is the biggest number. A is the bigger number. Right? Because A is a major axis. And so that's true. That's checking just to make sure.
Okay, so the one we were considering yesterday, and his animal, was like, so you go back to school tomorrow, and then the nurse was like, can you go back today? And then he's like, I don't want to go to math. I think I'll just sleep today.
Be glad that your paper doesn't look like this. How old was he?
11.
And he already hates math. Just like with parabolas, does it make sense that when you put a center somewhere else that you're just going to have H and K filled in all those places? So instead of 0, 0, like we're just going to have H and K's in here? Is that, if you have any clue what I'm saying? Why? Like what don't you understand? You've seen that this just is like the last one I gave you, except for instead of nothing up here, we just have H and K up here. Right? And H and K just means the center. Well, there's some examples in there. The length of the major and the minor axis never changes, like even if the center's somewhere else, like it's still 2A and 2B. But the foci and the vertices are going to change because just like with parabolas, it's a lot messier when you put the center with a vertex somewhere else because you have to consider that. And so definitely you're going to want to be looking at this as you do some of these. But I'm going to show you how hopefully you can kind of think through it. The big things I want you to know is A tells us the major axis, B tells us the minor axis, whichever one's under the biggest number tells you which way it opens. And then the foci are on the same line as the major axis. The vertices are the endpoints. We'll talk about that in a minute. We're going to spend a couple days on this, so hopefully it'll kind of make more sense. But these are kind of your 2 pages that you want to look at. So let's just jump in here to do what? I'm not. I don't think so. I'm pretty sure it says nothing is allowed, but I'll check it. Does this look like the equations for these ellipses that I just gave you? No. To have an equation of an ellipse, x and y are never going to have something in front of them. And actually, even more important, to have an equation for an ellipse, it's always equal to 1. So that's where you get these fractions from, okay? That's why they wanted us to review rational functions, because these kind of look like rational functions sometimes. But if I want this equal to 1, do you agree I could divide everything in here by 12? And I would get that. That's an equation of the ellipse. Looking at it, can you tell me which way is it going to open? Is it going to open, not open. Which way is going to be the bigger axis? Is it going to be long ways or up and down? Because x has the bigger number under it, right? So we say that it has a horizontal major axis. So what can I say from this? Well, this is x squared over a squared. So can I say I know that a equals 2? And this is y squared over b squared. So what does that make b equal? Square root of 3. They're not going to always be pretty. So I just want to show you that you can make a sketch of this without having to do all these things, find the vertices and the foci. They want you to do that, but I just want to show you how to graph these pretty easily. Well, I didn't give you a better graph on here, but let's make some points here. There's nothing on the top, right? It's just x squared plus y squared, which means the center is going to be at 0, 0. The major axis is 2 times a, or what I always remember is if you know which way the major axis is going, you go a to the left or a to the right, or up and down if it's going up and down. But this one's going left and right, which means I know my major axis is going to go 2 this way and 2 this way. And that means my minor axis goes the other way, and it's 2 times b. b is the square root of 3, which isn't very pretty, but that would be like 1.7 in each direction. And if you connect those lines, does that make a ellipse? Let's see if that's Mr. Levy on your back. You can go down there and see if you can confirm. So although there's a ton of stuff on those formulas I gave you, if you know the equation, if you know a and b and the center, you can make a graph. Does that make sense? They ask us to find the vertices and the foci. The foci have c in it. C is never in this equation, but you can find c using that Pythagorean relationship. But remember that a is the biggest number. So if we're looking for c, remember that it's a squared equals b squared plus c squared. So that's going to be, what, 4 equals 3 plus c squared. So does that make c just equal 1?
Why are we trying to find C?
Because it says find the foci, and if you look at your formula for foci, it has c in it. What if you don't have a formula on the test? How do you know how to write the foci? The foci are always on the major axis, and since it's at 0, I'm just going to go c to the left and the right of 0. So that's just going to be plus or minus 1, 0 would be my foci. And I think that's what we wrote out, c, plus or minus c, 0. So like if you had to label those would be your foci. Your vertices are the endpoints of your major axis, which we found already. You can just look at it and count what the endpoints are. But the formula for the vertices, if it's left and right, is just plus or minus a0, because you go a to the left, a to the right. So that's why we can say plus or minus 2, 0. Questions
So
on
you don't
that?
actually have to add the H to it.
Because what is h in this problem? See what I'm saying? So that's why when you deal with the ones that are 0, 0, they're so nice, because 0 plus that is just 0. Look at another one like this, just to make sure we got this down. Maybe we can just make a nice graph, build up our confidence. Then we can look at one that's not so nice maybe. So how about you try to graph this one? Or at least find A and B, which way it goes, and then I'll do it for you. Rick, you think we can just sleep in 10 hours a day? I'm so tired. Jake's not here again. Yesterday, Nick just went to the Shakespeare party. Can't sleep. I gotta deal with this desk. I'm trying to prepare my costume for the talent show tonight. But I need to take this back off and color it, otherwise we can't really see it so well.
That's what all of our team group.
Miss Spy and I are performing together.
I'll just have to record it, because I want to feel that.
I hear the tennis team's gonna be pretty interesting.
I've got
Cora said today is the first day they practiced with music, and it was really hard. She's like, with music was really hard. Like, yeah, she might need to practice. She's like, we might do it without music, just so we can do it at our own pace.
You know the little guy, Dan, couldn't stand up tall. Some kids do a magic trick.
A equals 8, B equals 6. How do I know? Because A is always bigger. Which means if A is bigger, is this one going to look like the last one, or is it going to be switched around? Yeah, because So that means, again, I know I'm at 0, 0 because there's nothing on the top. So can I just go 8 to the left and 8 to the right? And this one would be, the minor axis would be up 6 and down 6. Did you see pictures of that volcano that erupted in Chile? It's kind of crazy.
Oh no, is that Ella's thing?
It's not. She said that there's like a ton of volcanoes in Chile, and so like it's not uncommon for them to erupt often. But this one's just so close to town, and so that's why it's making a lot more news because they're having to evacuate a town where there's a lot of volcanoes that are close to towns, and so they erupt and it's not a big deal. But yeah, I saw a picture on last night, and it looked like there was like lightning in the. It was crazy. We should look at it next time. Do you agree with this statement? A circle is just a special type of ellipse. Because what would the major and the minor axis of a circle be? They'd be the same, right? So the closer that your major and minor axis are to each other, the closer that it's going to look like a circle. Whereas if this was like 1 and this was 8, that's going to look really elongated. We're talking about that more tomorrow, Monday I mean. But yes, a circle is a special type of an ellipse, just like a square is a special type of a rectangle. All right? Mine does not look very good.
Wait, a square is a special type of.
Yeah, the definition of a rectangle is just 4 right angles and opposite sides are equal. Does a square meet those requirements? But a square just has an extra thing that all sides have to be equal. So we say a square is a rectangle. Every square is a rectangle, but not every rectangle is a square. Some crazy geometry.
I think this is interesting because class I've been in area 30 is a graphic design. One tool we use is called the ellipse tool. But you can use it to make a circle too, which makes sense. The circle's just a circle.
Yeah, a circle just has a major and minor axis that are exactly the same. So, all right. What if I gave you one like this? Same idea. You could list all the stuff. You can write it all out if you want. But the big thing is, if we wanted to find the center of this, just like we find the center in circles and in parabolas, it's HK. So what would the center of this ellipse be? -2, 5. What else is different about this one? Y is over the bigger one. So I want to point out, A is not always just the first one, right? A is the bigger one. So in this case, we can say we know that A equals 7 and B equals 3. That's all we really need to graph this. But if they ask you to find the vertices or the foci, that's where you're going to use those formulas. But instead of starting at 0, 0, we're going to start at -2, 5. And now remember that my major axis is going vertically now, which means this is going to go off my graph, right? 1, 2, 3, 4, 5, 6, 7. Because I'm going to go 7 up and 7 down. And I'm going to only go 3 to the right and 3 to the left. And that's going to look like a pointy football. Does that make sense? Just so you can see where the formulas come in, if we talk about the, Mr. Love. And then Mr. Love doesn't.
Oh yeah, he told me that he was like talking to Rose class that he saw me walk down there and then let me tell you.
I just assumed it came back so quickly that he wasn't there.
Oh no.
If they asked you for the vertices, right, the vertices are the endpoints here, which if you graph it, you can just tell me what they are. But that's why hopefully the formula makes sense. You start from the center, and you add and subtract A. So that's why the formula is H plus or minus A, and you keep the K the same. So we could say this is -2 plus or minus 7, comma 5. So -2 plus 7 is 5, 5. And negative 2 minus 7 is negative 9, 5. Is that right? No.
So what's the first?
No, don't write that down, kids. I wrote the vertices for going the other way, didn't I?
Yeah, 'cause that's for horizontal.
I did it for going horizontally. But what's changing? Is the horizontal one changing or it's changing vertically? I'm trying to show you that you don't need a formula sheet. I'm trying to show you that if you just think through it, you're going to figure out which way is correct. You know what's happening. And so like I wrote that wrong, and I realized I wrote it wrong because that's not right. The H is staying the same, right? Like I didn't move from negative 2, but what I did is I moved up and down. So that's why H is going to stay the same, and we are going to add and subtract A from K. And you can look back at your formula sheet to get that, but I'm trying to show you how you can think through this if you don't get a formula sheet, which I'm afraid that, you know, I know you think I'm going to cave in and let you. But because if I give you a formula sheet, here's why I think they don't let you have a formula sheet. If you have the formula sheet, you're not really thinking about it. You're just blindly plugging numbers into where letters are. If you don't have a formula sheet, you have to think, what is a foci? How do I find the foci? What direction am I adding or subtracting to do that? So 5 plus 7 is 12, and 5 minus 7 is negative 2. And you can check that that's true.
Oh, well, you could just.
You can just find it if you graph it, right?
Oh.
Always. Yeah. The foci is the part that you can't just find. You have to find C to find the foci, which means you have to do that Pythagorean theorem. So it doesn't say that, but we're going to do it anyway. If I was going to find C here, remember that A squared equals B squared plus C squared. Is that true? 49 equals 9 plus C squared. So C squared is going to equal 40, and it's better to just leave it as not a decimal, right? It's better to leave a radical. If you're going to graph it, then you can give me the decimal, but I'm going to say that's 2 radical 10. And again, think through it. The foci are on the major axis, which means the foci is going to look just like the vertices in that the H is going to stay the same, and then I'm going to take K, and I'm going to add and subtract my C value. And that's what the formula says, H, comma, K plus or minus C. I'll look at the test and stuff a little closer as it gets close to time to kind of tell you this kind of stuff you need to know. But you can think through those if you need to. The other thing I want to talk about is just like with circles and just like parabolas, what if they're not in that squared form? Can you complete the square to put it in standard form? And I know that shows up on the test for these different conic sections. Kind of the further we go with conic sections, the crazier that these start to look. Remember with a circle, the number in front of x squared and y squared is going to always be the same. And so when you solve it, you get x squared plus y squared equals something, no fractions. For an ellipse, we're going to have some fractions here, but step 1 is to recognize that we have to complete the square if there's an x to the first power, a y to the first power. So the first thing that I'm going to do is I'm going to regroup this. So I'm going to say 9x squared plus 36x, leave a spot to complete the square. And I'm going to say 4y squared minus 24y, leave a spot to complete the square. And then I'm going to move that negative 36 over. We did this with circles. The difference is now we're going to have fractions in it because it's an ellipse. One of the things we're going to talk about next week is looking at an equation like this, how to tell what kind of shape it's going to be by looking at it. Is it a parabola? Is it a circle? Is it an ellipse? Is it a hyperbola, which is the other one we have to talk about still. And we're going to talk about rules for that. Half? Oh, I can't take half of 36 yet, right? I got to factor the 9 out. If you did that all in one step because you were thinking ahead. My brain is not allowing me to do that. Factor the 4 out. right? Remember, you can't complete the square if there's a number in front of the square term. Because I'm just grouping those together. Want to divide everything by 9 eventually. Am I going to add 4 here? What do I add to the other side if I add a 4 here? Ah! You have to multiply by that number in front. So you do the same thing over there, but you have to remember that that 9 is out front. It's going to be multiplied by it. So if you have a number out front, you're not just adding 4. You're really adding 36. 4 times 9. It's been a while, right? So on this side, when I add 9, right, I'm also going to add 9 times 4. Just switched around. It's all come together. So this becomes x plus 2 squared, y minus 3 squared. And does that just equal 36 over there? I have a negative 36 plus 36, and plus another 36. If you ever get a negative number over there, it probably means you forgot to multiply by that number in front. That's a common mistake that happens. With our circles, it worked out always that these were the same numbers, and we could just divide it over, and we could get our radius. With an ellipse, remember that you always want it to equal 1, so it should work out every time that when you divide by this number, that these numbers cancel out, and what usually happens is they just go to each other, right? So if I divide everything by 36, I get x plus 2 squared over 4 plus y minus 3 squared over 9 equals 1. Which way is this one gonna go? Long ways or sideways? Because that one's bigger, right? So it's gonna go vertically. We don't have to graph it. But we want to be able to put them in standard form, completing the square. I know the formulas kind of seem a bit overwhelming, but again, just try to think through it. If you know the shape and you know what those words mean, then hopefully you can kind of talk your way through it. Questions about that? That's all the notes I have, isn't it? So I did make a few more copies. Notice I only gave you 5 homework problems because I'm the nicest teacher in the whole world.
How many ABC problems?
0. I think I included the rest of chapter 11 in here, so keep track of this. But you're just doing 1 and 6 and 11. 1, 6, and 11 have the same directions. They say find the vertices and the foci, sketch its graph showing the foci. That means you do have to find C on that. Number 11, you do have to complete the square on. And then 15 and 18, they give you the picture and they want you to write the equation, so it's kind of working backwards. On Monday, we'll talk about what if they gave you some information, could you write the equation? And we'll talk about this thing called eccentricity, which is kind of exciting for us. Not that much stuff left in this chapter, kids.